Today we're going to be looking at the ambiguous case in the law of sines. So, you're going to need pencil and paper for notes, your graphing calculator, preferably uploaded with the triangle solver program, because we're going to use that during today's lesson, and hopefully you have your brain. Now, also before we begin, you should already have some prior knowledge of the law of sines when you're given any two angles and one of those sides. This is specifically to examine the ambiguous case, but don't worry, we'll review a little bit. So, the law of sines. Why do we need it? Well, we need it in order to solve for the missing side lengths and angles in an oblique triangle. And an oblique triangle is simply a triangle without any right angles. Now we can solve for these missing values using the ratio of the sine of an angle to the length of the side opposite that angle. And the reciprocal of this ratio also holds true. You can see the top definition there. The sine of my angle A is to the length of my side A, as the side of my angle B is to the length of my side B, as the sine of my angle C is to the length of my side C. And underneath there is the reciprocal definition, and this also holds true. So, if you're solving for an unknown angle, you want to use the top definition because you're already on top. And of course, if we want to find the length of the side, we're going to use the reciprocal definition. Now, as I said before, we can easily use the law of sines if we have two angles and any one side. This is the case when you have angle-angle side or angle-side angle, because there's exactly one triangle that satisfies these measurements. However, if we're given two sides and any angle, such as side-side angle, it's possible for there to be no triangle, one triangle, or two triangles that satisfies those measurements. And we call this the ambiguous case, because we don't know what kind of triangle we have. So, for the ambiguous case, first we break it up into whether or not our given angle, which we'll call angle A, is obtuse, meaning it's greater than 90 degrees, or if it's acute, meaning it's less than 90 degrees. So, two cases relate to when it's obtuse, greater than 90 degrees, and four cases for when it's acute. So let's go ahead and look at the case when my angle A is obtuse or greater than 90 degrees, because there's only two cases and we'll go ahead and get them out of the way. So, when angle A is obtuse, or greater than 90 degrees, all we need are three pieces of given information. Here you can see you're going to be given the side, the length of side A, the length of side B, and your angle A. So, case 1. We have that angle A is greater than 90 degrees, and if the length of side A is less than side B, then as you can see from the picture there, my side A is actually not going to be long enough to reach the base of the triangle. So in this case, we have no solution. And that's it. Now for case 2, again, my angle A is greater than 90 degrees, but this time the length of side A is greater than the length of side B. Well again, if we look at the picture, our side A now reaches the base and we have a triangle. And in fact, since angle A is greater than 90 degrees, it's going to be an obtuse triangle, because we know that the definition of an obtuse triangle is a triangle with one obtuse angle. Now let's take a look when our angle A is less than 90 degrees or acute. The first thing that we want to do is calculate the height or altitude of our triangle. And that's done by simply taking the sine of angle A times the length of B. And you can see on the bottom there, it's simplified for you. H is equal to the sine of A times the length of side B. So, we have four pieces of information that we're going to use to examine the last four cases. We have side A, side B, our angle A, and the height, which we calculated ourselves. So let's take a look at that. Case 3. So, our angle A is acute, which is less than 90 degrees, and A is less than H. Well, now we have the problem again, where our side A is not long enough to reach the base of the triangle. So, in this case, we have no solution. The next case. Let's say that angle A, again, acute, but this time it's equal to H. And you can see from the picture there that A is actually equal to H. Well, this is pretty cool when this happens, because now we know we just have a right triangle. So we don't even need the law of sines, we can just go back to solving our triangle using our right triangle ratios, as we've learned previously. Now case 5. Again, angle A is less than 90 degrees, but this time A is greater than B. So this information satisfies exactly one triangle. But, just so you know, it could still be obtuse or acute. So if you start off drawing your picture as the triangle is listed on the right here, which I tend to do, and you end up seeing that one of your angles is obtuse, then just adjust your drawing. It doesn't mean that you've done anything incorrectly. And finally, our last case. Our angle A is acute, and A is greater than H, but it's less than B. Well, in this case, we have two triangles that satisfy these measurements. So let's look at this first guy here. So, if I were to take my side A and swing it inward, then I'm going to have the next triangle, which is an obtuse triangle. But if I take my angle A and I swing it outward, then I'm going to have an acute triangle, and that's the one that's left. So we have two triangles that satisfy these measurements, and therefore we're going to have two sets of solutions. So our first example, we have that A is equal to 5 inches, B is equal to 12 inches, and angle A is 101 degrees. So the first thing we want to do is identify if we have a triangle. Well, the first thing I notice is that angle A is greater than 90 degrees. So instantly I know that there's only two cases that apply to that. And also I can see that side A is less than side B. So this looks like case 1 where there's no solution. But let's double check with our triangle solver program. So we're going to go ahead and start our program. Okay. We're going to do the triangle test. We're going to enter side A, which in this case is 5. Then we're going to enter side B, which is 12. And then finally our measurement of angle A, which in this case is 101 degrees. And sure enough, we don't have a solution because angle A is greater than 90 degrees, which means it's obtuse, and A is less than or equal to B. So for this problem, we don't have a solution. Now let's try another example. So now we have that A is 22 feet, B is 12 feet, and our angle is 42 degrees. First, I notice that my angle A is less than 90 degrees, which means it's acute, and A is greater than B. So this is going to point me to case 5. Now I could go ahead and calculate my height, but I don't really need it because I know that this is going to satisfy my case 5, where there's exactly one triangle with these measurements. And I'm going to go ahead and check it with my program. So, go back to our menu, hit triangle test. We're going to enter our side A, which was again 22 feet. Our side B was 12 feet. And our angle A was acute, and it was 42 degrees. So sure enough, we have one solution, but remember, it can be an obtuse or an acute triangle, but it's only going to be one of them. Now let's look at example 3. Now I can see that A is equal to 12 meters, B is equal to 31 meters, and angle A is equal to 20.5 degrees. So the first thing we're going to do again is identify how many triangles, if any, we have. First, notice that our angle A is acute, which means it's less than 90 degrees. And I also notice that the side A is less than B, so this is looking like it might be case 6. But let's go ahead and check our height to make sure. So again, our height is equal to the sine of A times our length B. Now it's going to be an approximation again. So this is going to be the sine of 20.5 degrees times 31 meters. And we'll go to our calculator to figure that one out. And we're also going to check it. So the sine of 20.5 degrees times 31 meters is going to give me, and I'll take it out to about 3 decimal places, so we'll write it down as approximately 10.856 meters, because that is a length. And now, looking back here, sure enough, I can see that my height is less than my side A, and A is less than B. So this looks like it's going to be case 6, and we're going to check it using our triangle solver program. Let's go back to our program. We're going to enter side A, which we have 12 meters, which is 12. Side B will enter 31. And then finally our angle A will be 20.5. And sure enough, we're going to have two solutions. One of them is going to be an obtuse triangle, and one of them is going to be an acute triangle. So here we can see that we're going to have two triangles. Again, we have our picture here to help us out. Now remember, when I take my angle A and swing it in, that's going to give me the obtuse triangle, which is in the middle. And then if I were to take angle A side A and swing it out, I'm going to get my acute triangle, which is the last one. Now today we talked about the ambiguous case with the law of sines. And again, why do we bother studying? Well, the reason that we care about it is because when we're solving for the missing lengths and angles in an oblique triangle, and we're given two sides and an angle opposite one of them, which we denote as side-side angle, we can have no triangle, one triangle, or even two triangles that satisfy those measurements. So we need to examine it to figure out which one is ours. Now, the way we do this is, again, breaking it down into the case where angle A is obtuse, or greater than 90 degrees, versus when it's acute, or less than 90 degrees. Two cases relate to when it's obtuse, and the other four relate to when it's acute. When we go to solve an individual problem, the first step is to identify the triangle we have, if any, because remember there was a couple cases where it doesn't form a triangle based on the given information, and therefore the answer is that there's no solution. But if you do have a triangle, remember sometimes you have two, then you want to go ahead and draw out your triangle and label the sides and angles. Then you can set up your proportions using the definition of the law of sines or the reciprocal, depending on whether you're solving for an angle or a length. And then finally, just solve for the missing values in your triangle. And then you're done. That's all we have for you today. Good luck with your trick.